Welcome students. We'll be discussing here maxima and minima. In the previous videos also we have discussed so many points of introduction of maxima minima, first derivative test, and we have seen some problems also. Now we will use here second derivative test for finding out maxima or minima of the given function. So let us start with this question. Find the points of local maxima or local minima of the function fx is equal to x cube minus 6x square plus 9x plus 15. And we have to use here second derivative test. So let us see what is the characteristic of second derivative test here and what are the steps for using second derivative test for getting maxima or minima of the given function. In the first derivative test, we have seen that given function will be differentiated and the derivative of fx, I mean f dash x, will be equated with 0, and after equating with 0, you get some values of x which are known as points of maxima or points of minima. So up to this step, we have to do the same process. First of all, suppose if fx is a given function, then first step you find out f dash x. This is the first step. Second step, equate f dash x with 0. You will get some values of x. Suppose equating f dash x with 0, you are getting here x is equal to c. Here x is equal to c. This value c will give the point of maxima or minima. In fact, c is the candidate for maxima or minima of the given function. So up to this step, the similar pattern is there in first derivative test as well as second derivative test. But in this test particularly, we have to find out second derivative also, f double dash x, and we put value of x is equal to c here. Next step, fourth step, we put value of x is equal to c in second derivative of the given function. If this is less than 0, this point c will give maximum value of fx. Here we will get maximum value of fx, and if we get this much is equal to greater than 0, then we get minimum value or minima of fx. So students, we have to remember this condition carefully, and we can do now this question. So let us see how we can initiate. So first of all, we'll find first derivative f dash x. This will be 3x square minus 12x plus 9. Next step, we have to equate this expression with 0. So f dash x is equal to 0 gives us 3x square minus 12x plus 9 is equal to 0, or taking 3 common, that will be removed here due to this 0 in right hand side, or x square minus 4x plus 3, this is equal to 0. After solving this equation, you will get x is equal to 1 and 3. Here x is equal to 1 and 3 are the candidates for local maxima and local minima. So now we will use second derivative test to check whether these points give us maximum or minimum value of the function. and that we can do by putting value of x here in second derivative. So let us start with x is equal to 1. When x is equal to 1, so f double dash of 1 is equal to 6 minus 12, this is equal to minus 6, this is less than 0. So as per the condition, we'll have local maxima, therefore fx has local maxima at x is equal to 1. And what is that local maxima? We have to find out this value also. Local maxima of fx is equal to how much? We have to put value of x is equal to 1 in this given function. So that will be f of 1. So this will be 1 minus 6 plus 9 plus 15. So that will be equal to 19. So this is the maximum value, or you can say local maxima of the given function, and the point of local maxima is 1. Now we will check for x is equal to 3. When x is equal to 3. So f double dash 3 is equal to how much? Putting x is equal to 3 here, that will be 18 minus 12, this is equal to 6. This is 6. So this is greater than 0. This 6 is greater than 0. Therefore, this function fx has local minima at x is equal to 6. Now we can evaluate local minima by putting x is equal to 3 here. X is equal to 3. So local minima is equal to f of 3. Let us evaluate it. So this is 27 minus 54 plus 27 plus 15. This is equal to 15. So this is the value of local minima, 15. And the point of local minima is x is equal to 3. So dear students, in this way we can use second derivative test. Now let us see next question. Next question. Here given function fx is sin to the power 4x plus cos to the power 4x, and interval is already given here in the interval between 0 to pi by 2. So for this function also we have to find out local maxima and local minima. We'll follow the same method, same pattern. So first of all we will get first derivative f dash x. This is equal to 4 sin cube x into cos x minus 4 cos cube x into sin x, and taking 4 sin x cos x common, we are getting here sin square x minus cos square x. You know, this is equal to minus cos 2x. So, and here we will get sin 2x. So this is 2 sin 2x minus cos 2x, and this is equal to minus sin 4x. This is first derivative. Now second step, next step, we have to equate f dash x with 0. So now f dash x is equal to 0 implies minus sin 4x is equal to 0. Now we have to look at this interval. X lies between pi by 2. So considering that given interval, we can write therefore 4x, this is equal to pi, and x is equal to pi by 4. So this value x is equal to pi by 4 is lying in the given interval between 0 to pi by 2. So this x is equal to pi by 4 is the candidate for local maxima or local minima. This value of x will give local maxima or local minima of the given function. Now next step, we will get second derivative of this function. So f double dash x, we have to differentiate it with respect to x. So this will be equal to minus 4 cos of 4x. Now, by putting value of x is equal to pi by 4 here, you will be able to decide whether this function will have maxima or minima at x is equal to pi by 4, and we will decide with the help of second derivative test here. If second derivative of the function is less than 0, negative, the function has local maxima at that point, and if f double dash x is greater than 0, the function will have local minimum at that point. So now f double dash x is equal to pi by 4. This is minus 4 into cos of 4 into pi by 4. This is to minus 4 cos of pi, and this is equal to 4. So this is greater than 0. So the function has local minima at x is equal to pi by 4. And we can get the value of local minima by putting x is equal to pi by 4 here. So here value of local minima is f of pi by 4. So this is equal to sine of pi by 4 power 4 plus cos of pi by 4 power 4. This is equal to 1 by root 2 power 4 plus 1 by root 2 power 4. This is equal to 1 by 4 plus 1 by 4. This is equal to half. So this is the answer. This is local minima, and the point of local minima is pi by 4. This is point of local minima. So students, we can do these problems very easily with the help of second derivative test. Now in the next video we will see some more problems based on second derivative test, and we'll do some problems on areas and volumes of some three-dimensional objects. So students, I hope you might be getting benefits from my videos. So please subscribe my channel HiQ Learning, and please share these videos with your friends also. Thank you very much. Wish you all the best.